As the next application of integral to physical systems, consider gas contained in some vessel with pressure P, volume V, and absolute temperature capital T. And now imagine that one wall of this vessel can move as a piston by some distance dx. And we want to find the mechanical work that this motion is associated with. The total work, or the element of the work, is the force times the displacement dx. But the force is the pressure P times the area of the wall of the piston, that's denoted by S dx. But the area of the piston times the displacement is the change of the volume dV. So the work is given by PdV. P is the pressure and dV is the small change of the volume. Now consider the ideal gas described by the state equation PV is RT, assuming we have 1 mole of the gas. And assume that the temperature is constant, and we want to find the mechanical work done by the gas when it expands the volume. We can think of P as a function of volume V, and when T is constant, then from this equation we see that the pressure P is RT divided by the volume V. So up to some multiplicative positive constant, this is like 1 over x. So the graph is hyperbola. And when we start at volume V1 and expand the gas up to volume V2, then the total work is integral PdV, which has the meaning of the area of this region bounded by the graph of the function P as a function of V. And then the total work is the integral from the initial volume V1 to the final volume V2 of pressure P dV. And when we consider the isothermal process, when T is constant, then P is RT divided by V, and we can factor out RT, and we have integral of 1 over P, 1 over V dV from V1 to V2. And this is easy to integrate. The antiderivative is logarithm from V1 to V2. So we have RT times logarithm V2 minus logarithm V1. But if we want to use the volume V with some physical units, it is much more reasonable to write this as logarithm of the ratio, namely RT logarithm fraction V2 divided by the initial volume V1. Because then this fraction is dimensionless, its physical unit is 1, independent of the unit that we measure volume in. And logarithm of a dimensionless number is perfectly okay. So that was another application of the definite integral in physics.